Okay, so change of base is like the last thing that we're going to study with this. If we kind of look back where we've come, you know, the first lesson we had, we were just figuring out that logs are the inverse of exponents, that logs are used to find, right, to find the exponent. So when we have this, when we have 625 is equal to 5 raised to some exponent, right, we can label what the exponent and the base are, and then when we convert it, because this would be trial and error. You do 5 times, 5 raised to the third, 5 raised to the fourth. That'd be all trial and error. Sometimes it would be more difficult to figure it out that way. So instead, we use logs. You put it in log form, and first we were just practicing converting it. Today we would be able to solve this one all the way out. Okay, we'd be able to find the actual value for x. Okay, so then we learned about all of the log rules. We learned about these log rules. They function a lot like exponent rules. So if we're adding together two different logs with the same base, we can just multiply the two index values together, m and n. Division is subtraction. When you have an exponent, you throw it out in front. All these things are the laws where, we might have a situation where we have something like this, and then we, get into log form, we manipulate it, and then this is the very last step. This is the very last step right here, the change of base form. So with the change of base formula, the main thing to think about with this is a calculator only has base 10 options. And that's because a calculator is based on base 10. Base 10 is when you get to the 10th number, you add a digit to the next place value. And we think, well, that's just how math works, right? It's not just how math works. You can make a system of mathematics with any kind of base. Base 10 is what we're used to. Base 6, base 7, base 8, these are things that actually around the world, different cultures have had different types of math based on how they interact with numbers. So I don't remember the specifics anymore. It was years ago since I talked about this, but there's a country in Pacific Island country that is, the way that they would trade fish had a base 7 concept to it. So 7 fish would be 1 additional unit, almost like weeks. Weeks is a base 7 unit, base 7. Because what happens after the 7th day? You count that as 1 week, and then you start day 1, 2, 3, 4, 5, 6, 7, 2 weeks. Day 1, 2, 3, 4, 5. That's base 7. Okay, so if you think of it as, okay, well, in order for them to have a calculator that would have all the bases, it would just be endless. It would be endless. So instead, we use base 10, and we use the change of base formula to be able to calculate it because a calculator only has base 10. And in some ways, these are very abstract, and we're making it, we're bringing it to the base 10 world that all math in Western culture is based on. Okay, so the change of base sets us up with base 10. Now all we have to do is we have to see that 3 and 8, I think of them spatially as just on different levels. And what's going to happen with this, where we have log base 8 of 3, instead of log base 8 of 3, what we can do is a change of base. And what happens is the index ends up on the top, the base ends up on the bottom, and then what is converted in this fraction, now we have base 10, which aren't going to be, you might even just see this. This is the same as if it just said log 3 over log 8. Okay, I'm not going to put base 10 in there as we're doing these problems because base 10 is the standard, it's the basic. But log 3, now we can put this into our calculator. Now we can go here and we can put, 3 log, and this is an actual value. This is an actual value, okay? Log 8 is 0.9031, and keep about to the 10,000th place, 4 digits like this. You do the fraction, you get your actual value, okay? So what this is saying is that 8 raised to the 0.528 is equal to 3, rounded 3. And that's what the log problem was saying. It's saying, what is the exponent for 8 raised to some exponent to equal 3? And we found that out here. Okay. It's going to be like, as you're working through these, you're going to forget, okay, well, what is x again? X is the this is the situation. This came from 8 raised to the x is equal to 3. That's where this problem came from. We couldn't do this, right? That's really hard because you can't put 8 raised to the 0.528. That would be really lucky if you trialed that error and got that. So we change it into a log form, and then now we do the change of base to actually find what that x value is. So it actually, it works out. I told you that, today would be the last bit, and today's pretty easy, right? I mean, today is just split them up, calculator work, done. So let's look at a few examples, and I want you to work these out. So go ahead and get these on your paper as we go through them. First we're going to start here by changing this, because I don't know what 6 raised to what gives you 201. I don't know. Does anybody in here know that? No. So we have to use logs. Here's my base. Here's my exponent. Now the main thing to remember is that we use logs to find the exponent. So we're figuring out what the exponent is. So the exponent is always categorized as what we're trying to find when we do log. We have x is equal to the log. This is the base. This is the exponent. So log base 6 of the index here, 201. This is called the index. Okay. So now we have x is equal to log base 6 of 201, but it's log base 6. Base 6 isn't going to be able to be converted into numbers we're used to dealing with, which are base 10s. So what do we have to do? Change base. So we get x is equal to log of 201. You see how it's just a little bit higher, so it goes on the top, and divided by log of base 6. And these are numbers we can actually do. So I'm going to really work this one out mostly for us, and then we'll give a chance to figure out more. I'll give you more leeway on this next one here. Okay, so we have log 201 is 2.3031, and that's going to be divided by log of 6. So I put 6 in there, and then log button, and that's going to be 0.778182. So I keep as many digits as I can. I think I actually rounded the other one wrong, didn't I? Yeah, this should be a 2. So these are numbers we can actually deal with. I put this top one in there again. I divide it by 0.7782, and I get 2.96. Oh, well, yeah, let's just do that because it'll round all forever here. And then look what we did. We can go and see if this works. Because what we found, remember, is x, and that's this exponent. So if I go in here and I do 6 raised to the 2.96, I'm going to end up with something really close to 201. Yeah, 201.060. And that's just the rounding kind of errors that'll happen. It's going to happen. Okay. So let's try this next one. I'm going to let you do this one all the way out. Go ahead and first change this into a log. Change a base it, and done. All right, oh, that goes here. So I'm highlighting the base in pink, the exponent in fluorescent yellow. And then how about somebody in the chat, when you're done, let me know, put your answer in the chat, and I will see it. And who came in late? Who came in late? Brian. Okay. Okay. Okay, so I'm going to start working this out if you needed to see the next steps here. So remember, the logs help us find what x is. So x is going to be equal to the log base. So the base in an exponent problem is 3. The base and the exponent here have the same names here. We put the exponent out front because logs help us find the exponent. And then it's log base 3 because base of the exponent remains as base of the log. Base 3 of 64. So now we're ready to do the change of base all the way through. And I would say just focus on identifying what the base is, identifying what the exponent is. If you just organize 2 things in your head instead of 3, then it's just easier. I remember that the exponent goes out front here because we're solving for the exponent. Logs help us find the exponent. The base of the exponent becomes the base of the log. The index is kind of what's left over. Okay, so don't worry about what's the name of that thing again, where does it go? Just remember base and exponent where they go, and then the other number falls in. Change base. Let's say what to get. 64 log 1.8062 log of 3, 0.477 1. And then let's just divide those out. 1.8. See how I'm going to lose some digits here. So you would need a fancier calculator that can remember all the entries. 3786. Keep it like that. So here is my x value, and let's see if this works. So remember what we're trying to do. We found the exponent. Let's see if we put that exponent back in our original. 3 raised to the 3.786. And we end up with 64.029, and that's what we were trying to find anyway. 3 raised to that exponent gets us to 64. And now it's off by 2 hundredths, right? 3 hundredths, but that's just rounding. That's because of rounding, and that's going to be okay because we just don't have the calculators that can do that. So I'm going to give you probably. I mean, let me know in the chat. Let me know in the chat. Scale from 1 to 5. How do you feel about this? In here, pretty straightforward, right? It's like we've been dealing with it. Now it's just like that last little baby step. Okay, guys, good. Thanks for the feedback. Let's just do maybe one more like this then. The homework is even easier than this. This is going to access some of our rules, though. So first, let's go ahead and look at this and think about it. Okay, so we have addition going on. And I need to combine these. I'm going to combine these. It's going to be x is equal to what? Well, I'm going to tell you right now. It's log base 3. Tell me in the chat what goes in that parenthesis. What goes there? So these are more like the last homework. The last homework got us pretty far where we can combine our logs. But you're very close, very close, very close, very close. Let's look at the rule again. I think I got to bring the rules back. What's the rule again? The rule. When we had in the expanded form 2 logs with the same base being added, what do we do with those 2 indexes, m and n? Multiply them. Multiply them. So instead of 10, we're going to have 24. You see? Oh, yes, yes. We then can do log 24. Log 3. 24 log. All these years you've looked at that button. You're like, what is the log button for? And now you know. I mean, it's like all your answers here. Okay. 1.3802021 divided by 0.47712. 2.8020 4A.2.2. I see. I see. I think this is going to be helpful, actually. Let's do more of these example problems because we need to review the rules as well. So let's do this now. Let's do this sample problem. And there's not too much to do with this. We just have to remember this needs to go somewhere. So tell me in the chat, where is this 2 going to go? Where is this 2 going to go? It might not be an apparent. Apparent. Oh, what do you think? So if we remember here, we have the log rules for exponents. When the index has an exponent, you take that k value, whatever your exponent is, you put it out in front. You see how it's now k times log base b of n. So anytime you have an exponent on the index, just put it out in front. Put it out in front. That's kind of a unique log rule. And so really what this converts to next is 2 times log base 2 of 3. You see? And that actually gets us pretty far. Gets us pretty far here. We're going to leave the 2 out there. But this log base 2 of 3, we can do change of base formula. We just got to remember at the end, we got to multiply everything by 2. And that's the main thing that I wanted you to get out of this problem. So go ahead, work all it out. And in the chat, let me know what x is. What is x? All right, let's go ahead and work it out. 2 times, we'll put our values that are going to work out here. Log 3, that's that one, 0.477. 1. Log 2, 0.30102. Divide those, 0.4771. Okay, so what we get is 2 times 1.5849 times 2. We get x is equal to 3.1. I'm gonna put 169. I'm not gonna go all the way to that. All right, very good. You know, one more, then we'll call it. This one right here is the last bit. It has subtraction, so think about the rules here. I'll leave it out. That should give you the rule that you need right there. It's even a line. Even a line. So the key is in the expanded form, subtraction. What are we going to do with subtraction? We go from expanded form. The base stays the same. Notice how the b is the same for the compressed form here. But what happens to m and n? Since it's being subtracted here, we divide them. So we can go ahead and set that step up. Nice, Stephanie. Yeah, you're quick. I'm recording this. I don't think you missed too much here. So we're just doing this problem. We're trying to figure out what happens when we have it subtraction, and we just figured out we can combine it as division when we have two different logs being subtracted with the same base. Boom. Which is log base 7 of 4. And then change the base that, and someone in the chat, let me know what you got. So remember, we can change the base this equals log 4, log 7. All right, so they said thank you. And log of 4. Did I do that one already? 4 log 0.60205. Let's do a bunch of numbers. Then 7 log 0.84509. And we end up with 0.7124. Yeah, that's good. So remember, is that what you got too? Oh, there's another way to check that. 7. Yeah, that's right. Great. Nice. All right. The main thing for the homework, I only gave you 6 problems, really, just to more so practice calculated work. Okay. So it's 6 problems, and it is just applying the change of base to a given log. Honestly, you're just given mostly things like this, and you need to convert it into your final value. The logarithmic laws. This is the homework that I think most people need to focus on. This last step, the baby step we just learned, is like the last thing that you'll have to do. But just check out the homework assignment and give it a try. And then Thursday we'll start our midterm review. Check your Google Classroom. I sent some messages to a few folks because the Unit 5 test was closed on Monday, but I'm giving you till tomorrow night to finish it. So That is a hard deadline because I don't want to get too far into our midterm review and have people need to do that. Okay, so that's it. I'm gonna stop this.